Ask My Instructor 6.4.51. Find the volume of the solid torus formed when the circle of radius 6, centered at 7, 0, is revolved about the y-axis. Use the shell method. Below is a circle of radius 6, centered at 7, 0. The method suggested to us was the shell method, and in fact, if we revolve around the y-axis, the shell method, in my opinion, is usually the easiest method to use. So we're going to be using the shell method as suggested. A quick review of the shell method. If we revolve this rectangle of width dx about the y-axis, we get a cylindrical shell. The shell will have a radius of x, a height of f of x, and a thickness of dx. Suppose we were to cut the shell and spread it open. What is the volume of the shell? Well, the volume of the shell is going to be the circumference times the height times the thickness. So it has a height of f of x, a circumference of 2 pi x, and a thickness of dx. And this is the formula for the volume of a solid using the shell method. Now, we have a slight problem or a slight difficulty with the problem we are working on. The equation of a circle is not in function form. Now, we could write it in function form, but we would actually get two functions. So take that equation of the circle and solve for y. And you will see that you get two functions. One for the top, y equals the positive square root, and one for the bottom, y equals the negative square root. So these two functions would come from looking at the equation of the circle and solving for y. So we don't have one function, we actually have two functions. But this is not a very big difficulty to get around. Let's just think about what we want. We want the height of the yellow strip at location x. The height of the yellow strip at location x is just twice the height of the green strip. Now the green strip has height y equals the positive square root. So the yellow strip is, the height of the yellow strip is 2 times the positive square root. The radius is still x, and the thickness is dx. So the only thing we had to really work on was the height. So the volume of the torus is given by this integral. There's not a whole lot of cleaning up to do. We could integrate this after we cover chapter 8 material, but this problem is in chapter 6, and obviously we have not covered chapter 8. The instructions, in fact, say to use computer software. One of my favorite computer softwares is a free software that you can find at Wolfram Alpha. You have to know how to type in this integral. So let me show you how to do that. You use horizontal notation and you use the word integrate. Here's what you type in. Integrate y equals 4 times pi times x, parentheses, 36 minus parentheses, x minus 7, close parentheses, caret 2, close parentheses, caret 1/2. From x equals 1 to x equals 13. Then you hit the equals sign and wait for Wolfram Alpha to think through the solution. Now when you get your result, be sure to compare the Wolfram Alpha interpretation with what you meant to enter. Sometimes we think we enter one thing when we really enter another. So let's compare. Compare the integral at the top of the screen and compare the integral at the bottom of the screen. The only thing they did, and I'm not really sure why they did it, is they had they wrote -7 plus x instead of x minus 7. But other than since you're squaring, those two are definitely equal, and so I can trust the value that they give me. And this of course is in cubic units, so 4,974.28 cubic units. And my math lab asked us to do it to 2 decimal places, and there's my 2 decimal places. So I'm all done. Take care. If you have any questions, please let me know.